Greetings everyone, Quantum Unicorn here. In the last video, which was the distribution and frequency episode, we mainly focused on learning about the concepts of frequency, relative frequency of observed outcomes and distribution. Our emphasis was on explaining these concepts in statistics and introducing their applications in the finance field. Considering that you now have a good understanding of the above content, today we will do a detailed breakdown of the Python code for each module. By gaining a deeper understanding of the application of Python code in these specific scenarios, you will be able to better grasp the topic we are learning and lay a solid foundation for future learning. How exciting! Well, before we get started, please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Thank you. First, let's take a look at this code. The first line of code creates a pandas data frame called die with a single column that contains the value that's 1 through 6. And the second line of code uses the sample method of the data frame to randomly select two values from the die data frame. The replace equals to true argument means that each value can be selected more than once. The sum method then adds up these values, and the log method is used to extract the sum from the resulting series, which has only one element. And finally, the last line of code simply prints out a message with the value of sum of dice. So the overall purpose of these codes is to stimulate rolling two dice with replacement and computing the sum of the two values. The output of the code will be a message that says sum of dice is followed by the actual sum of the two dice. Okay, let's move on to our next module here. A trial equals 50. It sets the variable trial equal to 50. This variable will be used later to specify how many times to repeat an experiment. And the second line creates a list called results. Inside the list, it uses a loop to run an experiment 50 times. In each iteration of the loop, it samples two values from a die object. With replacement, sums them up and selects the first element of the resulting pandas series. This process is repeated 50 times, and the results are stored in the results list. The last line slices the results list and returns the first 25 elements of the list. In summary, this module runs an experiment 50 times where two dice are rolled and their sum is recorded. The first 25 results of these experiments are then printed out. Okay, let's move on to our next module here. Frag equals to PD data frame results value count. This line creates a pandas data frame called frag, which stands for frequency. It takes the results list from the previous code and converts it to a pandas data frame with a single column. Then it counts the number of occurrences of each unique value in the first column of the data frame and returns a series containing those counts. The resulting series is then assigned to the frag variable. And then we print out the frag series showing the frequency counts of each unique value in the results list. The sort frag equals to frag sort index. This line sorts the frag series by the index. which are the unique values in the results list. The sorted series is then assigned to the sort frag variable. And then we print out the sort frag series, which is the same as frag, but sorted by the unique values. So the overall purpose of this code count the frequency of each unique value in the results list and sort the resulting frequency counts by the unique values. The resulting sort frag series shows the frequency of each unique value sorted in ascending order. Good. Now let's take a look at this code. The sort frag plot. Well, this line creates a bar chart using the plot method of the sort frag series. The kind parameter is set to bar to create a vertical bar chart. The color parameter is set to blue to set the color of the bars, and the fixed size parameter is set to 10.4 to specify the size of the figure. This line will display a vertical bar chart showing the frequency of each unique value in the results list. The second line creates a new series called relative frag by dividing the sort frag series by the trial variable, which is equal to 50 in this case. This computes the relative frequency of each unique value in the results list. The resulting series is then assigned to the relative frag variable. The relative frag plot, well, this line creates a bar chart using the plot method of the relative frag series. The kind parameter is set to bar to create a vertical bar chart. The color parameter is set to blue to set the color of the bars, and the fixed size parameter is set to 10.4 to specify the size of the figure. This line will display a vertical bar chart showing the relative frequency of each unique value is the results list. In summary, these lines of code create two bar charts to visualize the frequency and relative frequency of each unique value in the results list, which are the sums of two dice rolls. The first bar chart shows the frequency counts of each unique value, while second bar chart shows the relative frequency of each unique value. Okay, let's move on to our next module here. Here, a trial equals to 100 sets the trial variable to 100, indicating that we will stimulate the rolling of two dice 100 times to generate 100 sums of two dice rolls. And then it generates trial number of samples of two dice rolls, sums them up, and takes the first and only element of each sum to create a list of 100 results. Each element in the list is sum of two dice rolls. Frag equals to PD data frame results value counts. This line creates a pandas data frame called frag that counts the frequency of each unique value in the results list. The PD data frame function converts the results list to a data frame with a single column, and the zero selects that column. The value counts method counts the frequency of each unique value in that column, and the resulting series is assigned to the frag variable. And sort frag equals to frag sort index. This line sorts the frag series by the index. The sorted series is then assigned to the sort frag variable. And then this line creates a new series called relative frag that contains the relative frequency of each unique value in the results list. The sort-frag sum computes the sum of the frequency counts in the sort-frag series, and then each element of the sort-frag series is divided by this sum to compute the relative frequency. The resulting series is assigned to the relative frag. The resulting series is assigned to the relative frag variable, and then this line creates a bar chart using the plot method of the relative frag series. The kind parameter is set to bar to create a vertical bar chart. The color parameter is set to blue to set the color of the bars, and the fixed size parameter is set to 10.6 to specify the size of the figure. This line will display a vertical bar chart showing the relative frequency of each unique value in the results list. In summary, these lines of code stimulate the rolling of 2 dice 100 times, count the frequency of each unique sum of 2 dice rolls, compute the relative frequency of each unique sum, and display a bar chart of the relative frequency. Okay, let's move on to our last module, distribution table. Here's what each line does. The X-distree creates a pandas data frame with 11 rows, indexed by the possible sums of 2 dice rolls, which are 2 through 12. X-distree prop sets the prop column of the X-distree data frame to a list of integers representing the number of ways to obtain each sum of 2 dice rolls. For example, there is only one way to obtain a sum of 2, which is by rolling 2 ones. But there are 5 ways to obtain a sum of 7 by rolling a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, or a 5 and a 2. And then this line divides the prop column by 36, the total number of possible outcomes when rolling 2 dice. This gives the probability of each sum of 2 dice rolls, assuming the dice are fair. In summary, these lines of code create a pandas data frame called X-distree that represents the probability distribution of the sum of 2 dice rolls. The data frame has 11 rows indexed by the possible sums of 2 dice rolls, that's 2 through 12, and a single column called prop that gives the probability of each sum. The probabilities are calculated by dividing the number of ways to obtain each sum by the total number of possible outcomes when rolling 2 dice. That's all for today. Congratulations on finishing this tutorial. Please subscribe to my channel, like the video, and share it out. If you have any inquiries or concerns, feel free to reach out and leave a comment. Well, thank you for your time, and I look forward to connecting with you soon. Goodbye.